welcome. This is a very casual conversation on how to use some of the highlights and details and features of the DISRP tool by TechFit. We are showcasing a vertebrae example. We're just going to show you through some of the basic usage and tools. Samuel here is with me. And let's do it. So the first thing that you want to keep in mind is that there's a bottom panel. It has three buttons. These they drive the flow of the application. You can open the part panel to the left. The part panel has some options to upload cases and such, but we're gonna focus mostly on the visibility options and the geometry and reference anatomical landmarks and reference geometry items. So here you can see that you can hide or occlude overall sets. So for instance, I'm displaying here only the disc in the in between of the vertebrae, and you can hide the cartilage here and just show the bone structure. Um, you can go a little further than that and select an entire set, and in that way, if you're going to do a translation operation or such, you should be able to move the whole set altogether by switching one of these two cases. You should be able to perform operations in different sets, or you can go as granular as do individual parts, like you can see here down at the bottom. There's different highlights here. You can highlight regions and move all over the place, and this allows you to do operations on single vertebrae and stuff. And this is very important because oftentimes you might find yourself in a situation where you might want to do translations or rotations or do annotations onto a specific parts of a biological assembly, and this will provide you with that specific ability. The one thing that you want to keep in mind is the open toolbar, the toolbar at the right of the screen. This one, rather than allow you to navigate through the application, they will enable different tool sets that will take place or take effect here on the left pane. For an instance, one of the things that it's more iconic of the DISRP tool is that we can have embedded communications within it. So, for an instance, there's two uh, annotations, number 1 and 2 here, and we created these sample annotations. For an instance, this is an annotation here, annotations initialize conversation threads. What's important about it is that you can have different topics within the case, and you can go into the message pane, which shows up at the right, and then you can answer, you can reply to this conversation. And right now we're making trivial chats, but in real cases, this might be an important channel of communications from the doctoral to the engineering team, and they disaggregate the topics into different places that are important in the planning of a surgery. Um, so that's one of the important tools that we have in this version of DISRP. Additionally, a doctor might want to highlight or use a particular point in the geometry to specify a procedure or to specify a sample taken or specify a part where an implant should touch on or such, and that's where we use the anatomical landmarks. So to create anatomical landmarks, you click there, and by default, your name in the application will show up. I'll talk about this later, but you can go and place your cursor on top of the target portion of the assembly and click. And this line here indicates that the landmark is about to create on top of that point. I can call this landmark double A landmark. And as you see here, there's a little cross with a dot, with a center dot, indicating that this is a point that you will afterwards use in the creation of geometry, or you can do that to specify the engineering team of a certain point that it's important during the planning. So those are anatomical landmarks, and you can You can access them also in the pane to the right here, as well as reference geometry. There's important navigation tools here. You can edit different views. You can rotate sideways, and there's some sort of visual tricks that you can do in the tool. So moving on.
Sorry. If I may add something to the anatomical landmarks, they are useful also for automatic creation of dimensions, like it is the case for cephalometries, for example. So you will be able to create a set of anatomical landmarks with predefined names also, like it is done in cephalometries, and the application will create the planning or the cephalometry for you, and it will be dynamical. So you will see the changes as you say translate or rotate a specific part, and see the change in the dimensions, in the angles and the distances.
Thank you, Samuel, for that. So moving on, and I want to try to exemplify on the go what you just said. Maybe I like to use this anatomical landmark to check on a dimension.
Yeah, you just click on it. Uh-huh.
And how can I change? How can I see the dimensions between it and another point?
Just select the other point. Yep.
Oh, okay. So I can click here on another point, and then I can see the distance from that very landmark to that point. And it could have been as well. It could have been as well done in the in between the two landmarks, right?
Yep, for sure.
So things that are interesting here is that you can see the full extent of the dimension, or you can limit that to the projection in different onto different planes. You can see here that for the most part that dimension goes along the x component, but there's other components to it that you can enable or disable, or furthermore you could restrict the dimension to the dimension that it's projected onto different planes, denoted here by the two colors, at the case of top bottom, right left, or anterior posterior. So this is one example of how DISRP can be used to create dimensions. So we have some initial versions of exploded views. We're working towards different techniques that might fit different cases. This is an ongoing work, but it's exciting already to see some previous results. One of the tools that I like the most is the angle dimension tool. I'm gonna explode back and select the angular dimension tools, and these are very useful to measure angles. And we have two different strategies. We have the 4 points or angle in the in between of two lines in space, and 3-point tool, which is angle in between of two lines in space that intersect at a common point. So you can create here a 3-point angular measurement. You do that by selecting a first point, midpoint, and endpoint. And we can see here that the opening it goes to 163 degrees onto the anterior posterior plane. You can measure the full Cartesian measurement will give you something close to 159 degrees. So this just goes to show our ability to do 3D measurements with very simple 1 or 2 click actions. So another very interesting tool is the rotation and translation tool. In here, you are allowed to do rotations and translations over the entire assembly or the sub-assemblies or the individual part. For this portion, I'm gonna exemplify it. I'm gonna try to translate a vertebra, for which I'm gonna double click on one of them, and you can see here that that cartilage that it's selected already. I can go into the translation tool, and it automatically sets the view at front because it's the closest view to the current one, and I can drag the pivot point to a place where I'm comfortable, and by hovering onto the arrows, hold clicking on them, and then moving them around, I'm able to specify translations, and this might be interested in the case that you're planning a surgery or an implant that leverages on the fact that things are moving and shifting around. You can dynamically switch to a different view, set left, and you can perform orthogonal translations that combine all together. So what's interesting about that is you can do translations that are concatenated in different planes by moving around, and they combine to an overall translation at the end. You might just click OK on that. I'm just going to disregard it for the sake of the example here.
Yeah, if I may add something, you can also specify the translations and rotations um, by via input on the left side panel. You just type the amount of translation or rotation, and the piece or the part will be translated that amount.
Yeah, thanks, Samuel. And so the final tool that we want to show is the geometry generation. Sometimes it's convenient to have to display certain strategic planes of cut or lines or points, and we have a section for that in the tool called reference geometry creation. At the moment, we're working our way to point and lines. So one could create a line, and that line might come from, we have various options for it. I'm gonna select 2 points on the mesh, one here and one here, and you can see that geometry has been created between those points in the form of a line. So this was very brief, but nevertheless a good explanation and showcase through the different capabilities that this DISRP tool offers for the surgery case planning of various types. In this case, the what you call it, lumbar, one of the lumbar cases. And so I hope this is explanatory, and we look forward to you using our tool. Thank you, Samuel, for being around and showing us, and I'll see you later.
It's my honor. See you later.